Hello everyone, my name is K. Rajesh. I am from CSE B section. Today's my topic is about interrupts. Introduction. An interrupt is a single signal emitted by hardware or software when a process or a event needs immediate attention. It alerts the processor to a high priority process requiring an interruption of the current working process. In IO devices, one of the bus control lines is dedicated to this purpose and is called interrupt service routine. When the device raises an interrupt at the process, the processor first completes the execution of an interrupt. Then it loads the program counter with address of the first instruction of the ISR. Before loading the program counter with the address of the interrupted instruction is moved to the temporary location. Therefore, after handling the interrupt, the processor can continue with the process. While the processor is handling the interrupts, it must perform the device that its request has been recognized to stop sending the interrupts request signal. Also saving the registers so that the interrupted process can be restored in the further increases the delay between the time on interrupt is required and the start of the execution of the ISR. This is called interrupt latency. Here the figure shows the interrupt controller where the devices are having the interrupts. Then the interrupt is disabled and the CPU interrupt enabled or disabled is shown here, and it is directly connected to the CPU. A a signal computer can perform only one computer instruction at a time, but because it can be interrupted, it can manage how programs or sets of instructions will be performed. This is known as multitasking. It allows the user to do many different things simultaneously, and the computer turns to different things, manage the programs that user starts. Of course, the computer operators at speeds that make it seem like all the user's tasks are being performed simultaneously. An operating system usually has some codes that is called an interrupt handler. The inter the interrupt handler properties the interrupts and saves them in the queue. If more than one is waiting to be handled, the operating system has another little program called the scheduler that figures out which program to control next. Types of interrupts. Interrupt signals may be issued in response to hardware or software events. These are classified as hardware interrupts or software interrupts, respectively. Here the figure shows the types of interrupts. Types of interrupts are of two types: hardware interrupts and software interrupts. And hardware interrupts is divided to two types: maskable interrupt, spurious interrupt. Hardware interrupts. A hardware interrupts is the condition related to the state of the hardware that may be signaled by the external hardware device. Example, an interrupt request IRQ line on a PC or de- detected by devices embedded in processors logic to communicate that the device needs attention from the operating system. For example, pressing a keyboard key or moving a mouse triggers hardware interrupts that causes the processor to read the keystroke or mouse position. Hardware interrupts can arrive asynchronously for the process clock and at any time during instruction execution. Consequent, Consequently, all hardware interrupt signals are conditioned by synchronizing them to the processor clock and act as only at instruction execution boundaries. In many systems, each device is associated with a particular IRQ signal. This makes this makes it possible to quickly determine which hardware device is requesting service and expedite servicing of that device. On some older systems, all interrupts went to the same location, and the OS used specialized instruction to determine the highest priority unmasked interrupts uh, outstanding. On contemporary systems, there is generally a distinct interrupt routine for each type of interrupts or each interrupt sources, often implemented as one or more interrupts vector tables. Hardware interrupts are further classified into two types, such as maskable interrupts. Processors typically have an internal interrupts mask registers which allow selective enabling the and disabling of hardware interrupts. Each interrupt signals is associated with a bit in the mask registers. On some systems, the interrupt is enabled when the bit is set and disabled when the bit is clear, while on others, a set bit disables the interrupt when the interrupt is disabled. The associated interrupt signal will be ignored by the processor. Signals which are affected by the mask are called maskable interrupts. Spurious interrupts. The spurious interrupts is a hardware interrupt for which no source can be found. The term the term phantom interrupt or ghost interrupt may also used to describe this phenomena. Spurious interrupts tend to be a problem with the wired or interrupt circuit attached to the level sensitive processor input. Such interrupts may be difficult to identify when the system misbehaves. In a wired or circuit, para- parasit- parasitic capacitance charging or discharging through the interrupt lines bias registers will cause a small delay before the processor recognizes that the interrupt source has been cleared. If the interrupting device is cleared too late in the interrupt service routine (ISR), there won't enough there won't be enough time for the interrupt circuits to return the uh, quiescent state before the current instance of the ISR terminates. The result in the processor will think another interrupts in pending since the voltage at its interrupt request input will be not high or not low enough to establish an unambiguous internal logic 1 or logic 0. The apparent interrupt will have no identifiable sources, and hence it is called spurious. Software interrupts. The processor requests a software interrupt upon executing particular instructions or when certain conditions are met. Every software interrupt signal is associated with a particular interrupt handler. A software interrupt may be intentionally caused by executing a special instruction that invokes the interrupt when executed by design. Such interrupts function similarly to subroutine calls and are used for various purposes, such as requesting operating system services and interacting with the drivers. Software interrupts may also be unexpectedly triggered by program execution errors. These interrupts are typically called traps or execution exception. Handling multiple devices. When more than one device raises an interrupt request signal, additional information is needed to decide which device to consider first. The following methods are used to decide which device to select first. Polling, vectored interrupts, interrupt nesting. Polling. In polling, the first device encoded with the IRQ bit set is to be serviced first, and appropriate ISR is called the service the time. It is easy to implement, but a lot of time is wasted by interrogating the IRQ bit of all devices. Vectored interrupts. In vectored interrupts, the device requesting an interrupt identifies itself directly by sending a special code to the processor over the bus. This enables the processor to identify the device that generated the interrupts. The special code can be starting address of the ISR or where the ISR is located in memory and is called the interrupt vector. Interrupt nesting. In this method, the I/O device is organized in a priority structure. Therefore, an interrupt request for the higher priority device is recognized, whereas a lower priority device is not. The processor accepts interrupts only from devices or processors having priority more than it. Processor's priority is encoded in a few bits of PS, and it can be changed by the program instruction that write into the PS. The processor is in the survived mode only while executing OS root lines, and it switches to the user mode before executing application programs. Conclusion: interrupts are the events that signal the processor to service the request. Interrupts can be caused by hardware as well as software. Hardware interrupts are of two types: maskable and non-maskable. Software interrupts are generally caused by exceptions and special instructions. Example: fork off. CPU handles the interrupts and on completion of the service request resumes the exception execution of the process from where the execution was left. Thank you.